All right. Hi. So we see it's 18 hours. We continue our conversation from where we left off, which was can't remember where, but we had started talking about I believe interaction. Could be wrong here, but probably interaction diagrams or something. Yeah, probably wrapped up on. We're looking at interaction diagrams. Okay, so the idea is, like I said, can you hear me, by the way?
Yes, sir.
Oh, great, thanks. So the idea was was we gloss over these just a reminder, we're glossing over all these different these different types of models. So context models, interaction models, structure models, and behavioral models. And then we're going to focus on some of them to try and appreciate the unified modeling language, right? So when modeling, with the exception of context models, once we start looking at, I guess we can call it a more hands-on walkthrough of how to create these models, you notice that we'll be latching on to the so-called UML specification, right? So it's a modeling language called unified modeling language, and we'll briefly introduce it at some stage, and once we start doing that. So we stopped off at the point when we were looking at we focused on two specific types of interaction diagrams. So we walked through use cases. Did we cover sequence diagrams? I wonder. Yes, I think we did. Yeah, we did. So we looked at interaction. We looked at use cases, use case models, and we also looked at so-called sequence diagrams, right? So these are all models that ideally use to come up with visual representations of how external entities get to interact with the system that you're implementing. An interesting thing that we highlighted, especially during our discussion of use cases, was the fact that they're ideal for eliciting more detailed requirements, right? So these sticky figures, for instance, are tremendously useful when you're trying to explain to your clients or your customers what sort of features the system is going to exhibit. We also highlighted the fact that the tabular notation, insofar as use cases are concerned, is appropriate for the developers. Why? Because it turns out that a tabular notation is a lot more intuitive for a programmer, right, than a narration, right, textual notation. So observe, if you give a programmer or a developer, right, there's a difference between developer and programmer anyway, but if you give a developer a use case that is represented like this, it's a lot more intuitive for that particular developer to be able to translate this into fully functional code, right, than just providing them with a textual notation like this, right? For one, it takes significantly longer for them to decipher the information that is in here. So it turns out that this is a lot more intuitive, right? This tabular notation, but this, on the other hand, this is more appropriate when trying to uncover additional details associated with requirements when you're interacting with your customers. Granted, it's not uncommon for you to come up with a use case diagram and just give it to the developer so that they know that they know that so when I'm developing this system, features such as the register patient feature, the unregister patient feature, the view patient information feature, the transfer data feature, and the contact features are going to be accessible to this actor, right, the medical receptionist. So using a more, I guess, a holistic use case diagram that includes all the actors and all the use cases will give the developer an idea of the specific features that they have to implement. Right? So you'd know that if you come up with if you come up with, let's say, use case diagram that has additional actors, for instance. I'm not good at drawing sticky figures here, which is quite sad, but that's neither here nor there. You'd know that this person will be able to implement the system in such a way that the rows associated with the different users of the system will be relative to how those things are represented in this diagram. Think about this for a second. When you log into Moodle yourselves, the things that you see, the things that you see in Moodle, if you log into Moodle, are different from the things that someone like Piela or someone like Lighton sees. You know why? Because we have different roles. Lighton is currently logged on as, I guess, editing teacher or something. You notice that I can edit things here, right? I can click the edit and then I can add resources. I can unenroll people, I suppose, I don't know. But observe, if I just try and visualize what sort of view I see when a student logs in, I will not have access to some of these features. Do you understand? Because the student actor was carved out in such a way that it only has access to specific features that were implemented. For instance, the student actor for Moodle is unable to edit anything here. You can't edit, right? Surprise, surprise. You can't delete anything. You can't add anything here. You are just a consumer, or you can add assignments, I guess, right? But you're just a consumer, right? So these are all different roles. The same goes for if I get back to my former role and I try and view a non-editing teacher, right? I'll change a role and I'll go to non-editing teacher. A non-editing teacher has far less permissions when compared to an editing teacher, right? So maybe this person will be able to perhaps grade assessments or something, but they won't be able to do more serious operations. They'll be able to perform the more sensitive operations, right? They're more or less like an observer or something, right? So all of these are actors. And interesting enough, actually, this is quite good. That Moodle is, I didn't realize that, I just thought about Moodle just now. The idea of Moodle is pretty interesting because it will come up very, very soon. The idea of Moodle is such that you're saying you have, and it's not me, right? If you look at, if I go back to my normal row, and then I again switch rows here, you notice that Moodle has, by default, there are these rows here. There's a teacher, non-editing teacher, student, and guest, right? So you can say you have a guest. I guess we can replicate this, I guess, I don't know. You have guest, you have teacher, right? You have the, I don't know, maybe, kind of, I hate this. Okay, guest, and then you have non-editing teacher, right? So about that, teacher. And then you have, what else do you have here? You have the student, right? Very important actor there. So you notice that by making use of these different actors here, right? You will notice that, where is generalization coming from? Non-editing teacher. I guess, I don't know. Maybe, yeah, I suppose. So you have guest, you have student, narrating teacher, and then you have the teacher, right? And of course, there are certain hidden roles that I cannot see here. Like you have people like an administrator, right? So a person who has root access to Moodle. So this can create other users. They can install plugins on Moodle, right? But anyway, what we're saying here is that when you're modeling this, right, you give this to a programmer and you explain to the programmer to say, you know what, Mrs. Programmer, I guess instead of saying Mr. Programmer, Mrs., say he's sexist, right? You know what, Mrs. Programmer, the thing here is Moodle. The thing here is we've identified these actors, and we have also identified these particular use cases. The programmer, by just looking at a use case diagram, and this is a detailed use case diagram which has all the features, right, associated with this system, all of them, explicitly laid out. So I'll have my use case here. Now I know I said don't use the login, right? Nobody does this, but we'll do this. We're using this as an example here. Please don't do this. Log out, right? You can say submit assignment, right? By the way, upload or create activity. By the way, Moodle create activity. Moodle is a very sophisticated application. There's a lot under the hood, right? There's a lot that goes on. I wonder if maybe we are replicating this. Let's just say Moodle use case. Oh, wow. Maybe it's there actually. Oh, thank the heavens here. Now, I'm sure we can, because it's an open source platform, I'm sure developers need to have access to this. Moodle, I wonder if we can find the actual Moodle.org, I guess. And if I were you, when you're dealing with this open source software tools, I would look up some of these tools, right? I would look up some of this information. You'll be able to gain access to things like interaction diagrams for most of these popular tools, these open source tools. It's unfortunate that we can't find the comprehensive use case diagram or use case model for Moodle here. That'd be nice if we could find it. There we go, right? So if you go to, I don't know if this has something to do with Moodle, but maybe not. But the bottom line here is that by giving a developer this information, if I just give you as a developer, if I just give you this, you should be able to translate this into code. Easy, right? Because you know that these are going to be mapped onto specific features, right? There's going to be a view workshop assignment feature, view example submission or something, right? And these are the generalizations I was talking about here, right? The interesting thing here is that what you will see once we start walking through this thing here is this idea of generalizing, generalization. This idea of generalizing, let's say actors, for instance, is pretty interesting because you know that a teacher and a non-editing teacher and the teacher have something in common, right? Understand? They have certain things in common. The only difference is that the teacher will need to be given slightly more access, right? Slightly more, they'll have access to features that the non-editing teacher would have access to. Another thing that you realize is that, where's the association? I'm looking for an association here because I have to look up dependency. I guess association. The other interesting thing is that what you immediately realize is that there are certain use cases that are shared amongst all the different actors. Like if we are foolish enough to include the login, the login and the logout use cases, nobody does that. What we would have to do is be able to explicitly showcase that all of these different actors will need to have access to the login and the logout, this is interesting. The login and the logout use cases. Is this making sense?
Yes, it is, but I thought you were going to give us some room for questions before we started the lecture. I was looking forward to that.
Oh, yes, well, just feel free and interrupt me if you have a question. Oh, I didn't give you an opportunity. Please ask if you have a question. You don't have to wait, by the way. At least not at third year, right? I don't know if third years wait, but third years are important people.
Okay. I can go ahead?
Yes.
Okay, on this one, for example, you've given us an example that the teacher has got some privileges to do some editing and the like, then a student is limited. Now, when it comes to the issues of a teacher having the privileges of editing, what kind of editing are you talking about? Does it involve some programming whereby if a teacher wants a certain function to be done in a certain way, then he can do his own coding and the like? Or I just want some clarity on that one.
No. So the editing I'm talking about is, you see, if you look at, we are using Moodle as an example, right? If you go on Moodle, Moodle has different features, right? There are, like for instance, if I log in as my normal role here, I thought I changed my normal role here, switch to, oh wow, I don't know. I want to log in. If I log in as my normal role, I go to ICT 1110. Observe what happens, right? Right now, if I click I don't know if you can see the tooltip here, the 10 editing on. I can do a couple of interesting things here, right? I can create assignments. Here is where it gets really interesting. I can back up. Now this is interesting. This call gear allows us to do different features. I can back up the Moodle site. I can reset this course completely so that all the marked assignment, everything that has been done so far will be completely wiped clean, right? I can edit grades, right? Student grades, right? This makes sense. This makes sense because I'm the course owner, right? I'm the person who is, I guess, the de facto instructor for this particular course. So guess what? I should be able to edit the grades for this course, right? I should be able to go here and I suppose we should look at your course here, not the ICT 1110. I can go into the grade book, right, and be able to edit student grades once I mark an assessment, right? So I come here, I can edit the grades. But as a student, you can't do that, right? Because it makes no sense for you to edit grades. That would be silly and stupid, really, if we had students edit grades, right? So this is what we mean by editing. It's nothing to do with programming per se. For this particular example, it's to do with how Moodle works, right? Fundamentally, it's a learning management system. You use it to administer teaching and learning activities, right? And teaching and learning encompasses so many different things. You're uploading resources. You are initiating discussions so that students discuss. You understand what I mean? I don't know if I'm answering your question. Okay. Yeah, so here's the thing. So the key takeaway point here is if you come up with a detailed use case model, you can actually give the use case model to the developer, right? Something like this alongside this tabular notation. For each particular, now this, again, we got this in depth very, very soon, I guess it's Thursday or something. So each one of these, each tabular representation of this is going to be mapped onto these oval shaped these oval shapes here in the use case diagram, right? So a login use case will be represented by a separate table here. It has an ID, the name is login, it was created by who, Lighton, who last updated it. And this meta information, by the way, is extremely important when you're working as part of a group, because you'd have a number of business analysts that are maybe working on the SRS document. So you want to keep track of who was working on this. And this is tremendously useful for you guys because you're working in parts, right? Groups of 4s and 5s. So maybe Peter is doing this and Tinta is working on the other use case, for instance, right? And you have details on when the use case was created, when it was last updated, who last updated it, right? Important information. Why is this important? Because you want to be able to follow up in case you need clarification. What were you thinking about, Peter, when you created this use case, right? And then interesting things that we'll look at here is, description, actors, and the preconditions and the postconditions and the normal flow of events, right? As the user is interacting with the use case. So when a student is interacting with a login use case, what exactly is the sequence of events? I type in my logging in requires me typing in a username and a password, right? And the sequence of events is simple for Moodle, right? I log in use case, I type in username, I type in password, I press the login button. Now pressing in the login button will result in either of two things. I'll successfully log in or I won't be able to log in, right? And then I get a message. This is an alternative path. The system tells me invalid login, please try again or something. Anyway, but bottom line here is that we did highlight the fact that you can use this to be able to, you can give this to program and be able to do that. And then we also discussed sequence diagram, and we zeroed in on so-called, I mean, this interaction diagram, an alternative, a different type of interaction diagram, which is sequence diagram, right? Trying to model the flow of events, the specific flow of events. Now, what I was just describing, what happens with the use case diagram, is more or less like a literal translation of this flow here, flow of events here, where you have normal flow. Type in username and password. What is the system response? System will either, if normal flow, system will log you in or something, right? Now, writing down the normal flow of events as 1, 2, 3 is is not always beneficial. Yes, hi.
Yeah, before I forget, I've got another question.
Okay.
For example, you mentioned something like you can use, I don't know if it's a use case diagram or the UML diagram to generate code. So when for example, if you want to do that, how does it work when it comes to the issue of determining the programming language that you're going to use?
Yeah, so it's not the use case diagrams. I mean, use case diagram is a high-level representation of the system, right? Usually, you tend to generate code from structural models like your class diagrams. Here's it. Ooh. And tools like, I don't know, did you guys use Eclipse in 2010? Were you introduced to Eclipse? What IDE were you using?
Dr. Java.
No, that thing doesn't. Dr. Java is like is Dr. Java even an IDE? That's a text editor, right? Is Dr. Java an IDE or a text editor? There's a difference.
It's an IDE, sir.
Okay, it is a lightweight IDE. Yeah, but you want to use something. I don't know. I've never really played around with Dr. Java, but Eclipse is a classic example of something you can use. There are plugins that you can lump onto Eclipse, and Eclipse will allow you to generate code right from UML diagrams. Now, some more sophisticated tools like I remember doing this for Enterprise Architect. Let's see if we can generate. Oh, there we go. There we go. Oh, the gods have been kind to us today. So Enterprise Architect generate class diagram code. So using a class diagram, right, you can actually generate code, right? So it's specific types of models, Peter, right? It's not your use cases or your. Sorry about that. That was silly, really. But it's who does that with the background music in the YouTube thing, right? I do apologize for that. But it's class diagrams. Please watch that video. So if you use a software engineering tool like Enterprise Architect, for instance, it will allow you to generate using your class diagrams, right? So you come up with something like this, and by the way, we discussed structured diagrams just now. But if you come up with let's say a class diagram like this, right? And let's say this is now I like make up requests here, but this is okay, student, right? And so student class, right? You have a student class, and then you know that the student is going to have a student ID. What type is this? Int, right? I don't know, int or something. I think so. Default values. We're getting some of these things. And then you have something else like, what else does a student have? Students have first names, right? And I checked anyway. And this is like a string or something. Student will have maybe a last name, I suppose. And last name, the data type is a string also, right? I guess the values like default values or something. I don't know. And then what else does a student have? A student has a year of study or something, right? Year of study is like, it's an int or something. I don't know. and then because this is we talk about structural diagram just now, but I just want to highlight this idea of generating code, right? The operations, right? Maybe you say the student is going to have to submit makeup request or something, right?
We have a power cut here, so my laptop is about to go. I just want to ask over the previous recorded video. It's not showing on Moodle.
Oh, really? I thought it was. I'll work on it. If it's hidden, I'll unshare it. Okay. Yeah. So the idea about generating, yeah, we'll do that together with this one. The idea about generating code, right? Look at this for a second. If you look at this, you know that translating something like this into, if you're taking an object-oriented programming approach, translating this into code is pretty simple, right? Class, public class student, right? And then the attributes, right? The characteristics are going to be student ID. So you say private int student ID, for instance, private int first name, because I mean you have to hide these details, right? If it's a class, anyway. Blah blah blah, and then the operations, the methods you have: submit makeup request. Instead of you looking at this diagram here, and then I don't know if it's legible enough here. Instead of you looking at this diagram here, and then manually opening up your IDE, and then you say public class. I've forgotten my Java here. Is it upper class? I don't know. Who cares, right? Student, and then you have this, and then you have private int student ID or something. Private. Come on. Private string first name, right? Now, this is the thing about using other languages. I've forgotten that you need to delimit this. And then you have private string last name or something, right? Yes, should have used an IDE. And then you have public public, I don't know. Public, what is the submit request? What would you do? Public void submit. I don't know if it's public or something. Submit makeup request, right? Something like this or something. I don't know if this is how you do Java or something. 2, 3, 4. I just say this is a method or something. Observe, right? Instead of you doing this, instead of you wasting time, these tools like Enterprise Architect, I'm not sure about Dia here, will allow you to just right-click this and just say generate code. And then you have a scaffold, right? You just specify the programming language, and then you have a scaffold of this, all the different classes that you have as part of that model, right? And in fact, it gets even better. You see, what you were taught in 2010 is that these attributes that you have here that are private, these are supposed to, because of information hiding here, these are supposed to be accessed in a certain way. You don't have direct access to these, right? This is where you have your set and your getter methods, right? So you would have had to, in fact, what you're supposed to do here, you're supposed to have crazy things like private getter methods, sort of setter methods or something. The setter methods is, are the setter methods void or public int get or set? These are void actually. Public void set student ID, right? This is what you do when you're modeling classes, right? And then you have public void. I don't know if I'm doing the right thing here. It would be nice if I set first name or something. You remember this? Did they teach you this? I guess, I don't know. Public set, hello?
Yes, we did that.
Yeah. So here's the thing, right? Instead of you doing this, right? What we're doing here, and you have like corresponding getter methods here, right? Public int get student ID or something. Instead of you doing what I'm doing right now, you can use the tool to generate the setter method, because the tool knows, right, that when you have an attribute that's defined as private, you need set and getter methods for this. So instead of you redoing these things, the tool automatically generates this for you. So that's the essence of generating code, I guess, by by using a tool like Enterprise Architect. I hope that answers you. I don't know if Peter is still around, but Peter had asked a question about that. Yeah. Is this fine? All right. I don't know. So the focus of our discussion of this so-called structural models is just going to be on class diagrams. And the reason we do this, by the way, is that we're cognizant of the fact that you were introduced to all P concepts in 2010, right? And we know that in 2010, you are looking at yet another different language, but which is object-oriented in nature, PHP. Hopefully, you've already started doing this. And really, the idea of the all P concepts associated with PHP, the idea is the same, right? It doesn't matter whether you're looking at Perl, Java, or JavaScript. By the way, it is considered object-oriented, right? The idea is the same. It's just that the difference is in the syntax, right? So if you are going, as a group, you're going to decide to use PHP because you've seen just how wonderful, I don't know what's so wonderful about PHP, how wonderful PHP is after being introduced to it in 2010, what you should do is you should take an object-oriented programming approach, right? It will be a lot easier for you to create code associated with whatever it is you're doing. Do you understand this? So our focus is going to be on class diagrams, really. But fundamentally, these so-called structural models, and by the way, it's highly likely that in 2010, maybe the lecturer would decide to assume that you were introduced to all P concepts, so there is no point in him regurgitating what was introduced to you in 2010, just like I'm making this assumption right now. And so what he'll probably focus more on is on the syntax, the PHP syntax associated with all P concepts. So we'll probably discuss that as part of the syntax or something. I don't know if you've already started doing that, but anyway, so the structural models will typically allow you to map up the different objects associated with your system, right? Usually appropriate when we are developing a system that is trying to mimic what goes on in a typical organization. Remember, everything is an object. I don't know if you're introduced to that concept, to that sort of concept. And of course, there are corresponding relationships. So these models can be static, right, where they'll just show you the overall structure of the system design, or dynamic, right, in which case you're showing the organization of the system as it's being executed. And I do believe deployment models are probably a type of, I could be wrong here, I just want to confirm, structural models. I do believe deployment, you can go to give me a structural model. I think deployment diagrams are probably a class of structural diagrams here. Unified modeling language, let's look at structural. By the way, I do encourage you to go here as well. I don't normally encourage Wikipedia, but it's one of those rare instances where if I can go down to structural. There we go. So you notice, I don't know if you can see this, under UML, what I'm saying is our focus is going to be in class diagrams, but you notice that that in fact the structure UML diagrams include so many other different things. There's other things beyond the class diagram. So there's deployment diagrams, extremely helpful once you're done writing the code and you want to deploy into production, or hopefully the system that you've implemented, right? So things like package diagrams and composite diagrams. I mean, some of these diagrams that I haven't used before myself, right? So what we're saying here, this point where we're saying the structural models can be static or it can be dynamic, where you showcase the organization of the system when it's executing. In essence, we're implicitly making reference to deployment diagram, right? So you can create these structural models when you are discussing the overall design of the system architecture, right? The system that you're implementing. And this will probably come up again once we look at, I guess, I'm not sure if we're going, maybe we should look at architectural patterns, I don't know. But anyways, getting on to what we are mostly interested in, which is one of the many types of so-called structural models, the class diagrams. we are going to spend time on this, and in fact, our walkthrough is going to emphasize or focus on how we get to arrive at this, not this, but how we get to arrive at how we get to create these things here, right? Something like this here, how we get to model these things. And I know it's going to be here's the class diagram. I know this is going to be revision. You must have done this in 2010, but we're going to revisit this again, right? So how we get to define these things, and how we get to model generalizations and aggregation and things of that note, right? Okay. So class diagrams are ideal when the development process is taking an object-oriented programming approach, right? So you're going to model a system based on the different objects associated with whatever it is you're developing, right? And all you do really in your class diagrams is you define associations that exist between your different classes. Obviously, I mean, a class is nothing more than a general definition of an object that you're trying to model or represent, right? So if you're one of those groups that is trying to come up with a system that involves a student interacting with the system, then you know that at some stage you're going to have to define a student class, right? And the student class is a representation of a student object, right? It's a thing that exists. Pretty much everything is an object, right? Microphone is an object, a house is an object or something, a table is an object. So the associations will be the links that exist between the classes, and they'll define the relationship that exists between the different classes. And we get to look at these different relationships that exist. Mostly it's things like generalization. So if you come up with, if we were to latch on to this particular example here, and we said we wanted to create a teacher class and a non-editing teacher class, would have attributes and operations associated with, hopefully, associated with a non-editing teacher, but instead of replicating some of the things that we have here, we can just generalize. We can generalize this, right? So we come up with these two classes, and then there's a generalization relationship that exists between a teacher and a non-editing teacher. And here's the thing, right? You will notice very soon that, in fact, what you're doing is you're reusing some of these models that you'd have implemented beforehand, like the use cases or the use case diagrams, to come up with your class diagrams, right? Easy stuff. So this is the modeling normally takes place early on, right, in the software development lifecycle phases. Just because, I mean, you're trying to get a better understanding of the different sort of objects that you'll be working with as you're developing this system. So just an example here, we're just showcasing two entities here, right? Two classes, a patient and a patient record. And you notice that this directed line here is just showcasing the type of relationship that exists between a patient and the patient record. So a one-to-one sort of relationship that exists. And I think these examples that I'm showcasing here are not your classic, maybe there are associations. I'm trying to think here. This could be an ER diagram, if I'm not mistaken. It looks like an ER diagram. Let me just quickly check. Trying to check if it's available under the UML specification. Anyway, right. So looking at this MHC PMS application, again, we're just showcasing the different relationships that exist between the different classes or objects, right? With specifics of I guess you look at these as being the multiplicities associated with the different classes here. And specifics of what happens relative to each of these different entities. So we're saying a condition is diagnosed with a patient, right? If you look at it on the flip side here, we could say a patient is diagnosed. I don't know if we can say the same thing, say a patient is it as diagnosed with a condition as well? I don't know, right? I don't know if it goes both ways, but in certain instances, the phrasing is obviously is relative to the first class that you're making reference to here, right? But key takeaway point here is that we're just showcasing the different relationships that exist between these different classes here. Again, deriving these classes is contingent on you having done an exhaustive elicitation process where you identify the requirements associated with your system. Hopefully you would have already come up with your use case diagrams and the interaction diagrams perhaps, and then based, you use those things as input to come up with your class diagrams, your structural models. So in terms of the specifics of what your typical class diagram is composed with, the UML specification requires that you come up with this diagram on the right here, right? Where you have a rectangle that has 3 sectors. The top part represents the name of the class. The middle part will be composed of the attributes or the characteristics associated with that class. And then the last portion will be composed of the operations, right, or the methods associated with that particular class. Now, depending on the tool that you are using, there are certain, and we will have to look at how Lucidchart gets to represent these, but there are other additional, there's additional syntax that you get to include here to signal the fact that a method is private, for instance, if it's public, or a class is private or public, right? This is usually things like a plus sign will mean that something is public, a minus sign will mean that something is private. The syntax that you use to specify default values associated with attributes, for instance, right? If you remember, when I was going through this representation of this class diagram, at some stage when I was doing this, right? If I go here and go to the attributes, you notice that the value here, I can say student number is 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh wow, why isn't this there? So you notice that if I do that, there's this default value that comes up because I've specified that in the event that no default value is no value specified, the default is going to be that. And we discussed this in 2010, right? I guess maybe the first name would be no name or something. No name or something. I don't know if somebody with no name as a name or something. No name, no last name or something. Right? I mean, so there's different ways of looking at depending on the tool you're using here. You also notice here, in my case, are you still there? Hello?
Yeah.
Yes, we are.
Oh, right here.
Oh, thank you. I was worried there for a second, I don't know. But so there's other syntax that we will see. So if you look at the visibility part, you see the plus signs that I have alongside these attributes or the characteristics. It's because the visibility is set to public, right? It's OOP, right? So I could decide to say, well, this is silly, really. This was supposed to be private, actually. I choose that this is private or it's protected, and you notice that it's changing. It's a minor sign now. Just go this class scope. I'll change this to private. They're supposed to be private here. Because it turns out if these were not private, I guess if you're using a tool like Enterprise Architect, you won't be able to automatically generate your set and your getter methods. Pointless for you to have set and getter methods if your characteristic or your attribute is public. Who does that, right? So this syntax, I mean, we'll look at, right? And it turns out that they're extremely important, especially if you're thinking or you're wanting to automatically generate code, right? Because these things that you're seeing here will signal what you're going to see in the final source code that is going to be automatically generated for you. More importantly, when you give this to a programmer, if you're not the one writing code, when you give this to someone, they will know exactly how to translate this into code. It's easy. You know, a minus is a private. It's a private attribute, right? I've forgotten what the protected attribute looks like. I don't know. Ah, it's a pound sign. Ah. Anyway, I'm not even sure if DI actually does implement UML specification 2.0, but maybe it does, maybe it doesn't. I wonder what Lucy Chat does. Sorry, was that the question? No. No. Are there any questions, by the way? It'd be nice if we could have it back and forth here instead of people just. Any questions? Didn't realize there were 9 people here. Wow, the apathy is 7 actually -2, but anyway. We'll just go ahead even if it was 1 person anyway. Right, so is there a question? No, okay. Good stuff. I mean, so if let's just try and see if we can get to class diagrams here from Lucy chart. Just try and see if the syntax is somewhat similar. Most of these tools will implement the most, I don't know if I don't want to use the word stable version of UML, but it turns out that I think if you look at the object management group website, I think the current specification that they have is 2.5 actually, but the differences are subtle, right? So you notice that same thing here, right? The plus sign here signals something else, and this is weird. This is sadder than, this is not as flexible as Dia. With Dia, you notice that you have a GUI that you specify, right? Drop down buttons and whatnot. But this web-based version, this Lucid chart here, you would have to, as you're defining these attributes, you would have to manually do this yourself. So you say minus account or something, bank address minus country or something, right? I don't know. That's unfortunate, but anyway, so this is the syntax, right? I mean, so we look at these different things again when we do our walkthrough, right? The fact that the parentheses will signal the fact that this is a method, and of course, I mean, if this thing falls into the last cluster or the last sector of this class representation, then you know that it's a method, right? Different things like providing the parameters associated with the method. You can see this in here as well, right? If it doesn't take in any parameters, that's fine. But if I go to under operations here, you notice this, guys, I do encourage you to use that. That is wonderful. Notice under parameters, I can say student make request. I will call this a makeup request is assessment type, right? Assessment type, the assessment type is, I guess, string or something. Default value, just call it 1110, I guess, I don't know. And then the other parameter that is obviously going to be there is going to be, what else can be there under the makeup request? I don't know. The date, right? Request date or something, right? The type is date or something, no default value. Do you understand this? And you notice that, so when you define the parameters, these pop up, right? Dia, you probably want to use a tool like Dia because it would make it a lot easier. It will make it relatively easier for you not to mess up the syntax. A tool like Lucid Chart, unless if I don't know this, you'd have to type in these things physically, right? Or manually rather, not physically. I hope there is a way of right clicking, but anyway. So you say this is a public method and then sample method, right? And then within this method, you have int x and then int string b or something, right? Yeah, so something of this sort. Anyway, I don't know, but we'll look at this, right? This will make sense very soon. So in terms of the different associations associated with these structural diagrams here is generalization, right? So in instances where you want to be able to latch on to pre-existing characteristics of another class, instead of redefining those characteristics, what you use is a generalization to signal the fact that there are certain things that you're going to reuse from from maybe the parent class or something, if you can use that for it, right? And examples of typical objects that you can generalize are things like animals, right? Because you know that you have different species of animals, or cars because you have different types of cars, or houses because you have different types of houses, right? Apartments and I guess townhouses or something. I don't know if they're called townhouses, right? And the idea is you predefine characteristics and operations or methods in the generalized class, and then the more detailed class is only going to include things that are specific to that particular class. And I hope you discussed this in 2019. I think you did. Yeah, so like I was saying, you're just inferring things that already exist from the superclass. Right, and this is, so identifying whether generalization is going to be applied to either one of your classes will be done as you're analyzing the requirements, right? Before you start writing the code. And it's almost always expected for object-oriented programming languages, right? That you take this approach, because it turns out that it's a lot easier for you to translate the design and the requirements into fully functional code that way. It's very easy, actually, right? It's very easy for you to translate. If you take an object-oriented programming approach, it's very easy for you to translate this into a structural model like a class, and then be able to map on the class diagram into fully functional code. Right? It's like one-to-one type of scenario, essentially. Right. So, like I was saying, so when you're generalizing a class here, the attributes and the operations in the more generic class, the superclass, as they introduced it in 2010. So, superclass and subclass. So the operations or attributes associated with the high-level class, which is usually a superclass, would be associated with the lower-level classes, right? The child classes or the subclasses. Essentially, what you're doing is you're trying to model what was introduced to you as inheritance, really, right? I don't know if you did this, but you know, so something similar to this, where you have a doctor, you have a general practitioner, you have a specialist, maybe somebody who's an oncologist or something. I don't know if there's such a thing as a hospital doctor. You have consultants, you have team doctors, flying doctors or something, right? So you notice that all these child classes or subclasses will be able to inherit the characteristics and the operations associated with the superclasses or the high-level classes. And how deep you go here is dependent on what sort of implementation you're looking at actually, right? Of course, in an ideal case, you wouldn't be able to translate easily code using this sort of representation. You need something that is more detailed, like this, right? So something that has a comprehensive set of both attributes and the operations associated with the high-level classes and the subclasses as well. And again, so some of these things, you'd infer them from the requirements. This is why requirements elicitation is important, right? So as you're asking the people, so how do you envision this particular user to interact with the system? Based on the responses that they're telling you, right, your clients, you'll be able to identify the different characteristics and operations associated with the classes, right? Assuming you're taking an object-oriented approach here. Then aggregation will just showcase exactly how the classes are composed with each other, right? So typically when you're modeling part of relationships, right? So things like, you know, that consultation details will be a part of the patient record, or patient details will be a part of the patient record as well, right? When you go to the hospital, your patient record will have your details, right? What is your name? Where do you stay, right? What is your age? So that's all a part of the patient record. So you can model that sort of relationship using aggregation, right? Again, we'll look at this in more depth as you're walking through this, how we get to derive these things using Lucidchart or a tool like Dia, right? A tool like Dia is able to help us model where is our, there we go, aggregation, right? Right, so something of this sort here. So I wonder, can't think of an easy example to Moodle aggregation using our student example here, but or student record, right? A student record, student record, student record, right? An aggregation relationship that exists between students, because the student details here will be part of this this thing here. Yeah, so these are things that we're going to look at. Don't worry, this is why sometimes computing can be fun, because it's like you're playing, right? And what better way to make a living playing, right? Anyway, can't make a living by dancing in a nightclub. Maybe there are people that do Zondo or Bantu or whatever. Anyway, so here's the thing, right? We're going to continue our conversation of like behavioral models on Thursday, and then hopefully we should be able to, if we happen to wrap up model-driven engineering, the discussion of model-driven engineering on Thursday, then on Friday we immediately start doing this walkthrough. So we'll double back to context models and then start going through these different types of models in succession, so that we see exactly how we get to create them. Unless if there are any questions or concerns, complaints, suggestions, any other comment you might have. If you're even there, are you even there? But, you know. Are you alive?
Yes, we're here.
Oh, all right. Good to know you're alive. See you on Thursday. Has any one of you already arrived on campus? Really looking forward to seeing you in masks, right? I've never seen you in masks, especially that I've known you for the last 3 years now. I'll see you on Thursday. If you're planning to travel between now and whenever, safe travels. See you soon. Bye-bye. Thank you.